So, number one here, the basics of an ellipse. I look at this and I can tell it's an ellipse. How is this different than a parabola? Both x is squared and y is squared. They're both squared. Okay? That tells me it's an ellipse, along with the fact that it's a plus sign, but we'll get to that later. Okay? So, the first thing we want to do is identify the center. Okay? Before, when we did parabolas, we looked for the vertex by looking at what was in parentheses with your x and your y. Is there anything in parentheses with my x right now? Is there anything in parentheses with my y? So where do you think my center is? Nope. We're going to write that in real colors, but 0, 0. That's the center. There's nothing with my x in parentheses. There's nothing with my y in parentheses, so my center is at 0, 0. Okay, so my center is right there in the middle. Easy enough. Okay, once we've done that, we're going to look at the numbers underneath the x and the y. Okay, if you look at that formula again, it has these numbers are squared. Okay, they're being squared. You can look at 25 and think, yeah, I can take the square root of 25 and take the square root of 16. We're going to take each number and we're going to square root them. Okay, what is the square root of 25? Yeah, plus or minus 5. We're just going to call it 5 for our sakes. Technically, it's plus or minus. We're going to call it 5. Okay? That 5 is underneath your x. Okay? It's underneath your x. When you think x-axis, which direction are you going to move if you're going to move on the x-axis? Left and right. Okay? We're going to move left and right. So from your center, we're going to square root whatever's underneath your x, and it says 5, and we're going to move that many units left and right from my center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the edges of my ellipse. Underneath my y, there's 16. I'm going to square root it. It tells me 4. What do you think I'm going to do with that 4? Up 4 and down 4. Why am I moving up, down, up 4 and down 4? It's the y-axis. I'm moving on the y-axis. 1, 2, 3, 4. 1, 2, 3, 4. There's my shape. I'm going to draw an ellipse. Good enough. There's my ellipse. Okay? If you were just drawing it, you'd be done. That's as easy as it is. Okay? I have now made my ellipse. It's not a hard thing to graph it. Okay, labeling it's just tedious. It's not actually hard, it's just annoying. Okay? The thing it asks you to do is label the ends of the major axis, or the vertices. Okay? So, there are two axes in this problem. There is this axis right here, and there is this axis right here. Which one of those two, green or purple, do you think is the major axis? Green. Any guesses on why the green one is the major one? It's bigger. That's the easiest answer. It's big. Okay, if I'm major and you're minor, I'm bigger than you. Okay? I'm the major axis here. It's the longer of the two. So we're going to write the endpoints of it. So it's that dot right there and that dot right there. I just want to find that ordered pair. So this dot right here is at negative 5, 0. And that one over there is 5, 0. Done. That's all I'm asking for. Where did you put your dots on the paper to make your major axis? So when it's asking for minor axis, you're looking for the baby axis, whichever one's shorter. Okay, so the endpoints of that. So that would be this dot right there and that dot right there. We're just going to label it. So it'd be 4, or 0, negative 4, and 0, positive 4. Yep. Yep, then the y would be the major axis. So the question was, if you went more up and down, then yes, that would be your major. If you go more left and right, then that one's your major. It doesn't always have to be left and right or up and down. Good question. Last thing we got to do is the foci. So if you think about that picture in the back where we put the pieces of tape, the foci are the pieces of tape. Where did you tape down this thing in order to go around it? So in our solar system, it's the sun. The sun is one of our two foci that it revolves around. Okay, there's technically another one as well. Okay, so when we look at this picture, the way we're going to do that is always going to be the same, and it's going to be similar when we get to hyperbolas. We're looking at the numbers underneath the x and the y. And we're going to use this thing called I'm going to call it the foci equation. It's always the same. We're going to take the big number on bottom minus the small number on bottom, and it will be equal to c squared. Okay, that's the equation we're always going to use. The big number on bottom minus the small number on bottom is equal to c squared. Okay, so for this problem, what's the big number on bottom? 25. So I'm going to write down 25 minus the small number on bottom, the little one. 16. Big number, little number. 25 minus 16 is going to be all equal to c squared. So 25 minus 16, 9. So 9 is c squared. So if 9 is c squared, what do you think your c value is going to be? My c is 3, and that is the distance to the foci. Okay? Foci is just the plural of focus. Remember on parabolas we had a focus? There was one of them. Well, now we got two, so we call it the foci. Okay? So we're going to go 3 units each direction to get to our foci. You've got two choices. You can either go up and down 3, or you can go left and right 3. Anybody want to guess on whether we go up or down or left and right? Left and right is the correct answer. Anybody want to guess why it's left and right? It's the major axis. It's the bigger one. Because it's longer left and right, that's where your foci are going to be. The green line we said was the big one. That's where we're going to make our foci. So counting from that center dot, we're going to move 1, 2, 3 to the left. And I'm going to put I always like putting an X because it allows me to remember it's there. And 1, 2, 3 the other way. Those are our 2 foci. Those would be the taped pieces of thing on the backboard. Pieces of thing. Yeah. Deal with it. Okay, so my foci are at 3, 0, and -3, 0. Done. That's it.